Welcome to part 2 of SilverlightShow webinar on advanced WinRT. My name is Ralica, and I'm pleased to introduce today's webinar presenter, Gill Cleeren. Today he is going to discuss advanced Windows 8 Metro. And as usual, this session will continue for about 60 minutes. Then we'll have a short Q&A session at the end. So if you have any questions during the session, please send them using the chat option in your webinar panel. And after the presentation, Gill will respond to as many questions as we receive as is possible. And if there are any remaining questions, we'll get a personal response after the webinar. Before we begin, I just want to remind you that we have some ebook giveaways for joining our post-webinar survey and also for tweeting this webinar using hashtag webinar SilverlightShow. So, Gill, shall we begin now?
Of course. Good evening, everyone, and welcome indeed to the second part of the advanced WinRT discussion that we started out last week. So again, we are going to dive in some topics that you may already have heard about, but haven't really gone deeper into. So the level of this talk is going to be, let's say, a level 300 as well. So we are going to, we're not going to do level 400 yet. I think the time isn't ripe yet for that. So that's going to be something for later webinars. Today we are going to focus on some stuff that I think will be useful in your endeavors in Windows 8 application development. So my name is Gill Cleeren. I'm working at Ordina, which is a large consultancy firm in Belgium. I am a regional director and a Silverlight MVP and also a Telerik MVP. I'm a regular speaker at many conferences and also doing quite a lot of webinars at SilverlightShow. You see my email, my blog, and my Twitter here. So if you have any questions, do not hesitate to contact me via any of these means. This is my second book that I've written, which was released last April. It focuses on Silverlight 5, hence the title, Silverlight 5 Data and Services Cookbook. It focuses on the enterprise level stuff in Silverlight, so things like MVVM, WIA services, but also Windows Phone development is in there. And many of the things that are covered in that book are also applicable to your Windows 8 development. So it's certainly everything that you read in this book, let's say 80% or so, is going to be applicable directly for Windows 8 Metro style applications as well. You can win, as Ralica just mentioned, you can win some stuff. There are some ebooks to be won by entering the post-webinar survey. 3 ebooks of your choice from SilverlightShow. And you can also win the ebook version of my book by tweeting about this webinar using the hashtag webinar SilverlightShow. All right. Very quickly, some practical stuff, yes. So questions, send them through the Q&A window. We'll do them at the end. And if you can't attend the entire webinar, don't worry. We will send you a link after the webinar containing the video, and you can see it at your own pace later on. So what are we going to discuss today here? So it is part 2. We are going to discuss some topics that I think are useful and you will come across in your regular application development. We are going to start with a look at localization of Windows 8 Metro style applications because applications have to be deployed via a Windows store. It is very vital that your application may have to be translated. And how do you do that? We're going to look at that. Then we're going to take a look at async as well. There's a lot of buzz around async development. It makes asynchronous development much easier. But I notice with developers that I've talked to, it's not always clear how it exactly works. And we're going to dive in that as well. We're also going to look at accessing and working with files. so on the local system, and also the ability for Windows 8 Metro style applications to save data locally and roaming. I'm going to show you a short topic on reusable components built using WinRT, and then we're going to take a look in much more detail at background tasks, and also we're going to look at lock screen applications, so applications that can run while your Windows 8 machine has been locked. And if we have time, there's a 2-minute bag of tricks, things that I've came across browsing the internet, things that I found out. So it's a bag of tricks, some small things that may be useful in your application development. So just as a reminder, last week we discussed in much detail periodic tiles and push notifications, as well as data and services. So that was an entire topic on data binding and OData access and background downloads. So mostly the data related stuff. So that was the things that we discussed last week. So this week we are going to start with part 2, and that is going to be the first thing is going to be localizing Metro applications. So localizing Metro style applications. When thinking about Windows 8 Metro applications, I think most people will already know that apart from site loading applications on a Windows 8 device, the way to deploy Windows 8 Metro style applications to any device that run inside the Metro environment, so Metro style applications, has to go to the store. And the Windows Store is going to be the place where you can install and search for Windows 8 Metro style applications. Because that store is a worldwide store, it is very likely that you will want to localize your applications so that users will actually be able to enjoy your application in their own language. Some application developers say, well, we do it only in English, but for some cultures it's very normal that the application gets translated in the local culture and local language. So here in Belgium, that is typical. Belgium has 2-3 languages that we speak. We speak Dutch, we speak French, some people even speak German. So more than many countries, we are confronted every day with multilingual applications. Because Windows 8 applications target the entire world, well, localizing the application is something that you will have to look into. Now, localizing Windows 8 applications is very similar to the format that we already had in .NET. It's not something completely new that they have thought out, at least from the bird's eye perspective, and from the helicopter view. It's more or less the same. It is part of WinRT, so it is not part of the profile, the .NET profile for Windows 8. It is actually part of WinRT, and it's 2 important namespaces that we have to work with, and it is Windows Application Model Resources and Windows Application Model Resources Core. Those are the 2 namespaces and classes of those namespaces that we are going to be working with. It is actually based on a system where we can both translate or localize strings as well as other resources, most importantly images. So those are the things that we are going to be localizing in the sample that we're going to take a look at in just a second as well. Now, the resource format that we know in regular Windows development, for example in WinForms, it is mostly built around resx files, so resource files. In Windows 8, we are going to be using something called resw files. So these files are not exactly the same internally as a resx file. The main difference is that with the resx file, there is always a strongly typed class being generated. That doesn't happen with the resw files. Basically, a resw file, and we'll see that in the editor in just a second, it's more or less the same as a resx file, but it is it's like a dictionary containing keys and values, and it is actually being binary compiled into something called a PRI file. That's what it becomes when it gets compiled. Now, in terms of working with languages, you may have already noticed that Windows 8 is the first operating system that allows you to do more than one language on the system. it is actually possible to translate your windows to enable or to use another display language in the operating system. You don't have to buy an English version and a Dutch version and a French version. It is actually just a language pack that you can install on the system to completely relocalize your windows. And that also results, of course, in other ways of working with languages from within the application. So in Windows 8, you have two things. You have a preferred language, and you have a list of languages that the user has installed on the system. And those can be found in the Windows application, sorry, the Windows globalization application languages, and then you can also declare one preferred language. We as developers can also override what the default language is going to be. I'm going to show you that in just a second. So assume that you want, there might be scenarios where you say, well, in my application, we are going to allow the user to say, well, this application should now display its UI in English instead of being the default Dutch, for example. So this is one of the new windows that is added in Windows 8. It is actually the place where you can add languages to your system. In this particular case, we have English as the default, and then we have some Hindi traditional as a second option in the application. So from WinRT, we can ask which are the available languages that have been installed on the system, and based on that we can decide in which language we are going to be displaying the language. So it allows more, it basically gives us more options in terms of localization. Now let's take a look at how we can do it technically. It is possible to do it directly from XAML. In Silverlight, many people used some data binding for this, perhaps in combination with an MVVM scenario. In Windows 8, doing the localization is pretty simple. What you have to do, or what Windows will do, it will automatically load in the PRI file, which is the index file of your resources, and from there you can go wild. Basically, in that ResW file, you are going to be using the same format, the key and the value, and then in your XAML code, you can, for example, say the ID of this textbook is going to be my textbook, and we use the XUID notation for that, and automatically it will translate things like the text, but also font sizes and stuff like that can be localized. Of course, we can also access those strings directly from code, and I'm going to show you that in just a second. So the PRI files, as mentioned, they are the binary format of your ResW files. They are the ones that get translated, or let's say compiled into a binary file, a PRI file, using a tool called makepri.exe. It is possible to directly dive into those PRI files. I'm going to confess I haven't done that yet. This is how such a file actually looks. You can dive into that to have deep control over how your localization actually, or your localization values will be used. But we're not going to do that. We're going to use it the simple way, and the way that you probably will use localization most of the time. So I'm going to go to the first demo, and so we're going to go to this one, localization sample. And of course, we're using the release candidate of Visual Studio 2012 still. We're all eagerly awaiting the RTM version. So at this point, we're going to use the release candidate. All right. So I'm going to run the sample first, and we're going to switch from the sample to the code. And it's quite hot here in Belgium at this point, and so my laptop is also getting very hot. Let's hope it keeps on working. So this is the first sample. As you see, I spent a lot of time on the layout. So the first one is we're going to use some resource localization or string localization from XAML. I click on this one, and you see a text. The title is in Dutch, by the way, for the people who don't know Dutch. The reason that it's doing Dutch in this particular case is that I have set from my application that Dutch should be the default language. However, in my system, I have not used. Let me go over here. Let's quickly show you what am I going to do? That is languages. That is in settings. And then show you languages. So as you see here, on my system I only have English as the default and the only language installed on my system. However, you saw that the UI, well, I just told you that it was Dutch. Now, it is using Dutch because from my application I'm actually overriding the default language. Now let's switch the application and go to English, set the language. Oops, what have I done here? Let's do that again. So now let's see that, and as you see now it also translated itself to English. Notice that also not only is the font, the text localized, but also the font size has changed because I also put that in my resource files. Okay, let's go to the code first. So that is XAML resource strings, that's this one. So in here we have a text block called explanation text block, and we have a welcome header. And in my solution over here on the right here, you see a folder called strings. And in that folder strings, I make a folder for every language that I am supporting. And in this case, that is the English language and NL, which is Dutch. In there, I placed a file called resources.rsw, and that resources file contains the key value pairs for my translations. And as you can see here, that welcome header has a font size of 35, it has a margin of 30, and it has a text, whereas in the Dutch version, you see that the font size is 100, the margin is 100, and that we have some text here as well, which was the text that you saw. This is how the translation is being done. Now, so my application can override the default language from the system. Windows will automatically keep track of what has been set in that area. So when we use the override default language, which is what I'm doing here on this particular line, Windows Globalization Application Language Primary Language Override, I'm going to set that to the selected language in the dropdown. From then on, Windows will automatically pick the resources in the resources.rsw file in that language in the folder strings. We can also, of course, do the string loading manually if you want to do that. That is also possible. In here, it says now load something, please. I'm going to load in this case, I'm doing it from the default resource files, but I can also do it from a specific resource files. So if you take a look at load strings manually, so this is what is being done when this one is being done when we asked to do the default loading. And so the loading from the resources.rsw file. So in here, I'm using something called the resource loader, and on that resource loader, I'm asking, get me the string that has the key string 1. If we take a look at the RSW file, you see that we say here hello world from resources. It will default to the resources.rsw file. However, if we say we don't want to use the default resource files, but we want to use our own, which you probably will want to do because you may get too many resources, you say I'm going to build a resource loader and pass in the name of the RSW file that I'm going to use, and then add that custom loader to get string hello world. And you'll see that in here, and that's the string that you saw appearing. We can also load images. In this case, it's going to show the US flag. If I would say I'm going to use the NL, again, set the language. I'm going to restart the application. And now take a look at the image. It's showing the Belgian flag where we speak Dutch in this case. Okay, let's go to, let's take a look at that very quickly. In fact, there's not that many things to see over here, so I'm going to say load images. And as you can see here, what I'm doing is I'm saying this image has to load images flag.jpg. However, it doesn't, there's no localization, it seems that there's no localization going on. However, in the folder images, there is a subfolder EN and a subfolder NL. And in there, you see the US flag and the Belgian flag being shown. Finally, last thing, it is also possible, and you will also probably want to do that in your real applications, it's possible to put your resources in a separate assembly, more or less a satellite assembly. And that's what I've done here. So I have created a separate a class library. It could be a WinRT component, but in this case it's not necessary because it's only going to be used from this application in C# as well. And in here I've done the same thing. I created a folder strings, and in there I created a folder EN and GA, which is for Japanese. And it is possible to use that from my code as well. So that's what I'm doing over here. So in here I'm saying make me resource loader that loads in the resources in application app resource class library. That's the one over here /resources. And then I can simply ask it to give me a string, and that is the string that you see appearing over here. So those are some ways of dealing with localization in Windows 8. These are, in my opinion, this sample is covering the things that you probably use most of the time. There are other ways, like I mentioned when we looked at the slides, to really dive and use the PRI files, but in my opinion, this will help you for 90% of the cases. Okay, let's continue our quest and let's take a look at async development. Now, async development is being hyped as the most important thing in Windows 8 and in C#5 and in general in .NET 4.5. It is actually an easier way of doing async that is being added. Previously, when you did Silverlight, you had to do a lot of asynchronous development as well. You asked or you called a service. You couldn't do that synchronously. No, what you had to do was you had to contact the service and then wait for the response to come in, and when that response came in, a callback was going to be triggered. That's okay. That's an okay way to work. However, it does tend to get a bit messy when you have many asynchronous calls being chained. So first you say I'm going to get all the images. When I get all the images back in the callback, then for each image I'm going to do this, and then I'm going to do that. You actually build up a chain of calls, and that tends to get quite messy. In Windows 8, and therefore in C#5 and in .NET 4.5, it is now possible to do that in an easier fashion using the async keyword. Now, async development is not something really new. It's basically saying that you can use your CPU for more than one thing at a time while not blocking the thread, CPU, or in general the thread that is being executed. It's the same thing as having a restaurant where each table would have would need a waiter. That's also crazy. You don't want that. Maybe you want it, but you're not going to get it. Let's say it that way. It's basically saying let's use that same waiter to wait on several tables at the same time. And in an analogy, in CPU terms or in computer terms, you have one CPU that will do many things in one go. It won't wait for one table to finish its food. It won't wait for one application to finish what it's doing. So if we take a look at the work that we get done with synchronous and asynchronous, and the first two lines of code over there, they are basically doing synchronous work. We see that we have a call, download data, and then we have when that data is finished, we're going to process it. So that is synchronous. So if you take a look, at what happens, you first call on to the download data. That may be an RSS feed or a stream of images coming from Flickr. Basically, what happens when you say download data, it halts. Things come to a halt. It doesn't move any longer. The thread is being blocked. After that, when the data is available, we can process it. But in the meantime, we haven't been able to do anything useful. If, however, we do this with asynchronous, an asynchronous way of working, here we now say we download the data asynchronous, we don't block the UI thread, and when that call comes back, we continue with this and this and this call, in this case, the process data. So download data async is being called. It automatically gives free the thread, opening it up for other work being done. in this case, the blue blocks are other calls that can be done while we are asynchronously waiting for the response to come back. When in the future it returns, we can do the process data. But we have done more work than the synchronous call, because when that process is done, only then we can move on with the blue blocks. That's what synchronous and asynchronous is all about. Now, how does it actually work? Well, there is an easy way of explaining it, and there's a very complicated way of explaining it. The easy way of using the asynchronous pattern in Windows 8 is shown here in General C#5. This is actually the way of doing async. In this case, we are going to get an RSS feed. We're going to get it asynchronously. What you see there is we use the web client. In Windows 8, it would be an HTTP client. Doesn't matter. This can be any type of .NET code. What we do is we say client.download string task async. That returns something of type task. And a task is something that can be awaited. So here we say await task. That gives you back like a handle to the thing that is being done asynchronously. And when that is done, the lines behind that await are going to be executed. When you use await, you have to use the async keyword in the method declaration as well. This is a way of signaling to the compiler, well, this method needs asynchronous stuff to be done. Why does that have to be there? Because of the fact what the compiler is generating for you. Now, this looks like if the following is being done. We say that we download the string task async, we get the task handle, and then we say when that thing is finished, continue with this and this and this line. So that is actually what it looks like. So the lines that are below that particular await, of the call to async, they are being awaited. So that is what it looks like. In reality, this is what it's doing. It is generating a state machine. And we are not going to go in there because I have not needed in my work that this is generating for me a state machine. This is the compiler doing it. There is an extensive blog post on MSDN that explains in much detail how the state machine is being generated for you. But in most of your, in general, you don't really have to know what it's actually doing. It is generating a state machine, which is why also the async has to be put on the method, because it needs to know what it needs to generate. The most important thing for us is that we don't have to write any callbacks any longer. We can do asynchronous development in a synchronous way of writing our code. So very quickly, I'm going to show you a bit more, one more sample, and then we'll take a look at the code. So this is a sample of async at work. So what you see here is two calls to download an RSS feed, and when they are both finished, we need to display something. Okay, so let's take a look at the message palm that goes on here. So first, the first line is going to be the process feed async. That is going to call onto the process feed async, and it encounters an await. That means that the var doc pass feed into doc is not being called before that download feed async is being returned. Okay, so that one is basically being parked, but it doesn't block here. It continues. The second, so that's what we get there, the T1. The second thing then, same thing, is the process feed async of the second RSS feed, and it also hits the first await before the download feed async. Still, it's not locked. It keeps on going, and that now hits the task when all that's also being awaited. So basically, we say to do in parallel the two process feed asyncs, and when they're finished, then we're gonna we're gonna continue. That's what it says over there. And at some point, the download feed async for the second one is, in this case, is going to be faster. Okay, so that means that it's now going to do the var doc, pass feed into doc, and then it's going to do another async that's also going to be awaited. And when that is finished, in this case, that is quicker than the second RSS feed, so it keeps on going. It now says write entry. And the same goes for the second RSS feed in fact it's a T1 RSS feed in this case, that's also going to do the parse feed, the asynchronous save doc async, and when that is finished, it's going to do processing. Remember, there was one more await, the one at the top, and now that is going to be called, in fact, it is now saying both tasks are finished. So the task when I was going to say, well, we can continue, and now it is going to say display message done. This is how async actually works. It's always very easy to do this. If we would have to do this in a traditional way of working, so with callbacks, it would work, but it would be very messy to actually get this right. This one is very clean. It is, in fact, nothing more than some compiler sugar, but it's behind the scenes. There's much more going on. It helps us to read much more cleaner code. It helps us to write asynchronous code in a synchronous manner. Let us take a look at async, and that is this one. Oops. Go away, please. There we go. So this sample is, when it loads, there we go. There we go. So this sample is going to use some async, and notice what will happen. So it is now using some categories on Netflix, and when I select one of these categories, at the top it now says 0, then it says 20, 40. So look what happens. It is not blocking my UI thread at all. I can keep on scrolling, and it is loading all the images and the titles in an asynchronous manner and adding them to the list that is being displayed over here. If you would have done this in a synchronous way, the entire UI would have been blocked, therefore reducing the responsiveness of my application. And it keeps on going, as you can see. It doesn't really stop here. It keeps on loading weird image covers. I was born in the late 70s, but anyway. So let's go over here. Let's take a look at the code. For some reason, it has collapsed everything. So it is this one. So in here, there we go. So oops. 1 second. There we go. So what we have here is a list, in this case a hard-coded list of movies, movie categories, movie groups in this particular case. And we are going to do initialize async, and we're going to do that asynchronously. Okay. Because of the fact that we don't want this on navigator to stop here, we're going to say do this asynchronously. And that's what we're going to do here. Okay. So let's go to this one. Okay, so these are all my groups, and for all the groups I want to load an image. That's the first thing that I'm doing. That was on the first screen. What I could do is I could ask Netflix to return me, I don't know how many, 20 images or so, sequentially. Not going to do that. What I'm going to do is I'm going to say for each group in that list of groups, load the image, and do that asynchronously. But this particular line here, and now let's put a breakpoint and let's run that one more time, you're going to see that it doesn't get hit before all the images are there. As you saw, the images have loaded. It goes quite quickly. And now only the string a equals nothing is going to be hit. Then we are hitting the breakpoint. So the load group images async is actually going to ask Netflix in this case to load an image. That's actually going to be the first image, and also notice it's going to do that asynchronously. So these calls are going to be launched all asynchronously, and when all calls have returned, only then the await task when all is going to say okay, we can continue, and then we're diving in here. And then the loading of the movies, well, load movies async is also being done asynchronously. First, we ask, get us, I think it's 20 images, and it keeps on going. As you see here, it's going to do that while through. It's going to keep on loading images, and it doesn't actually block the UI thread because it's only doing that in an asynchronous way using the await. All right. So using async is actually quite simple. The most important thing to remember is that when we hit the await, the lines that come below it are not going to be called before this call is actually being returned. So this is running asynchronously, and only then we move on to this and this and this and so forth. All right. Let's move on. Let's take a look at working with files and data in Windows 8 Metro style applications. This is also something that tends to confuse people a little bit. How can we, from a Windows 8 Metro style application, work with files and data? Well, in general, there's two big blocks of data that we can work with, or files and data that we can work with. On one hand, we have the ability to access files on the system. On the other hand, we have the ability to work with application data in the application's private store. Let's first take a look at files and folders. Metro applications run in a secure sandboxed environment, and they cannot simply say, well, let me directly read out a file in your temporary directory on the C drive. That's not possible. What is possible is allowing Metro style applications to access files in some specific directories, or using a file picker and then giving the Windows 8 Metro style application the ability to read or write a specific file using the file picker API. That's what you see there in point 3 and 2. So Windows 8 can enumerate files, it can read out files, it can write files to specific directories, and get access to other files using the file picker with user interaction. There's also an advanced query syntax available on a location that you can execute to find files that match a specific query. Let's take a look at that. So let's take a look at file access. So first we have the ability to use a file picker, and let us open the solution over here. So a file picker basically allows, through user interaction, to save or read a file, any file, on the local file system. Let's run this sample. You've probably already seen the file picker. It's more or less like your open file dialog in Windows. So here you have the ability, for example, to pick a file, and there we go. We pick this particular file, open up, and there you see that we have access to that file. We can read it out, and there we go. That is basically using the file picker. That is really easy to work with. I'm not going to show you the code for that. That's too easy, let's say, to talk about in advanced WinRT. Now let's take a look at file access. There we go. Let me quickly see if I have a file that needs to be deleted over here. Yeah, let's delete this particular file. Okay, let's run the sample. It's an SDK sample, so you have access to it as well. What we're going to do is we're going to write a file to the local file system. We can only read or write files to that file system in specific directories. Those are the My Documents, the My Pictures, the My Videos, and the My Documents. Only there we have the ability to read and write files if the developer has enabled the specific capability for the application. So what we're going to do here is we're going to create a file. There we go. The file simple.dat was created. If you take a look at that, there's not really much going on here. What you see here is first I am asking the system, give me, let's say, a pointer to the documents library. So here you see we get back a storage folder. And that is giving us the ability to read and write files in those directories where Windows 8 Metro style apps can have access. In this case, the documents library is available. The known folders has some other ones. As you can see, the documents, there's some other ones as well where you have ability to read and write, so music, pictures, removable devices, videos, and there you go. When we have that available, then we say create a file async, passing in the name of the file, and in this case we say replace existing, so do an overwrite of the file, and then the file has been created. Now that we have the file, we can start writing and reading the file, or we can also ask file properties. For example, here I'm going to write some text in that file. Hello, SilverlightShow people. There we go. Write that to the file. There we go. That has been written. If we take a look at how that has been written, there's several ways of doing it. In this particular case, we're using the simple file IO write text async to write to that particular file. That's done asynchronously because all file interactions happen asynchronously. It is not possible to do them in a synchronous way because every call that can take longer than 50 milliseconds has to be done by default in an asynchronous way. So that's what we say here. There's other ways of writing to the file. For example, you can say you can use the iBuffer and then write the buffer async. The iBuffer is basically a byte array that you're going to write. You can do that, and you can also use, and that is shown over here, the data writer on a stream. That's also possible to write data to a file, but the result is of course going to be the same. We can ask for the file to show its properties. In this case, you see that the file has a size of 28 bytes. We can copy files. And if you take a look at the documents folder again, if I still have it open, there we go. You see the file, simple DAT. I'm going to open that with Notepad. And there you see, hello, SilverlightShow people. There we go. So the text has effectively been written in it. Windows 8 can also delete a file. There we go. So it has access to all. It can delete files in your known folders enumeration. The only thing that you have to remember when you do this is giving the application the ability to, in this case, work in the documents library. If we don't have this capability, we will not be able to write or read files in that known folders documents library. Now that is one way. That is actually storing files. That is storing. Oops, that's not the one. There we go. Let's close this one. That is storing files in the local file system. But that might not be what you want. You may not want to, as a developer from a Metro application, to work with files that have been stored in the regular file system. If you don't want that, it might be interesting to use actually use data, application data. Now, application data is data that is managed and only accessible by the application itself. What I mean by that is, it is written and managed entirely by the application in a folder where only the application has access to, and there is a specific store per application, per user using the application. It is completely comparable with the isolated storage that we have in Silverlight. It's more or less the same concept that we have here, and we can also more or less do the same. We can either use settings, where we have a key value dictionary that's going to be saved, or we can also write files to a specific directory. Now, why do we want application data in the first place? It is very useful for data that you may not want to be reusing in your desktop, or that you may not want people using the desktop to have access to. For example, state has to be saved. Other scenarios, for example, if you're building an image editor in Windows 8, well, it might be useful to say, well, I'm going to save the user's work in the application data as a temporary save or even a final save. It is guaranteed to be isolated from other applications. So it's not possible to share data between two applications within the application data folder. It is removed automatically by the system, so it's managed automatically by Windows 8. It's automatically removed on uninstall of the application, and it's preserved on upgrade. There's no quota. As in Silverlight, we had the 1 megabyte quota and the 25 megabyte if we did an out of browser. Here we don't have anything in terms of quota. It is completely transparent for the developer. It's not you as a developer that have to go manage this. It's entirely transparent. So we have two ways. For the application data API, we can work in 3 ways. We have 3 options for that. We have the local, roaming, and temporary. Local means that it's only saved on the system. Roaming means that the data will be copied to the cloud and automatically synced to other devices where the same user is using the same application. So if I am using 2 laptops and on one I'm using my app, I'm saving the data in a roaming way, then it will automatically be sent to the other device. There are some limitations on how many times it's going to be synced. There's also a quota limit. That's, if I'm not mistaken, 300K, but it's a very useful thing. Think of scenarios where you would, for example, build a game, and on one, you're at home, you're playing the game, you shut it down, automatically the level that you were playing is synced basically to the roaming data in the cloud. You go to the you take the bus or you take a train, you open up your laptop or your tablet device, and you say, well, I'm going to continue playing here. Automatically that roaming data gives you the exact level. And you have temporary. Temporary could be removed at any time. So there you can store data that is not to be reused later on. So there's 2 things that you can do. You can use settings, or you can use application. You can use files. Settings is basically a key value where you can use or you can store settings. You can store settings in containers, 32 levels deep. So that's basically a way of grouping your settings, and that can be used locally or roaming. This doesn't work in a temporary way. Then you have application files, and there basically you can put in whatever you want. Each application has a root directory, and in that root directory there's 3 other root directories: local, roaming, and temporary. And there you can store files as much as you want. You can create directories and you can create files. This is where you would end up if you are building, let's say, Photoshop in a WinRT way. That would be your way of doing it. You would store the temporary images inside of probably the local files, because they might be too big for the roaming. Let's take a look at roaming in a sample. That's going to be this one. So I'm going to take a look at roaming data. All right, so opening up the sample now. There we go. Okay, let's go. And let's run the sample. So in this particular case, we are going to write data to local settings. What we are going to do is we're going to write a setting. We can read it out later on. So it already says here, hello world, so that means that I've run the sample already. This user, this device, and then I can retrieve that setting automatically. I can delete it. Let's restart the application. Now it shouldn't be saying, it says empty now. Write the setting. There we go. Kill it again. Restart it again, and now it should still be showing that setting. There we go. So this has been saved on the system, and it's persistent over application restarts and also system restarts, of course. This has been done locally. I can do this roaming. So if we take a look at the code, there we go, at the very top here. This is how you work with the application data. So the application data current gives you an object on which you have local settings, roaming settings. And let's open up the IntelliSense here. So you see here you have local settings and roaming settings. And you also have local folder, roaming folder, and temporary folder. These you can use, the local settings and roaming settings, to store keys, key value pairs, the folders to actually store files. When we have in this case, the application data container returned from the local settings, we are going to use that application data container to store, in this case, in a key, this particular value. And we can retrieve it later on as well. This is really useful to save state, to save other information between application restarts. All right. Let's quickly take a look at using WinRT components that are reusable. A reusable component, what I mean by that is a component that can be written in one language and reused in other languages. Traditionally, you would have used COM for this. Now, writing COM in managed code, COM components in managed code is really hard. This is how a very, very simple component would look in .NET. Now, as you can see, it basically comes down to using many attributes and many and GUIDs and stuff like that, so many ugly things that developers don't like to deal with. It's very difficult to do this in traditional managed code. However, when doing a reusable component in WinRT, it becomes very simple. As you can see, it is just a class with a method in there. Very simple to work with. Now, why would you want to build a reusable component? A reusable component is written in one language in WinRT and can be used in projects in other languages. So, imagine that you are a C++ developer and you are very good in writing code that does image manipulation, which is quite what C++ is very good for. So that would be the way of doing it. You write a C++ component, but you also want to enable WinRT developers using JavaScript or WinRT developers using VB or C# to actually use that component. You can do that using by following a couple of simple rules. And it also works vice versa. And what I'm going to show is I'm going to use a C# library in a JavaScript project. But my C# library has to follow a couple of rules. The first one, only public types can be, These rules apply, of course, on the public types. These are the rules. The API signatures can only be using WinRT types. Structs should not have private fields, can only have public data fields. The types must be sealed unless you're building a custom XAML control, and only system-provided generics can be used. All these rules, of course, apply only if you want to do reusable components between languages. If you are building a C# library and only going to be using it from a C# WinRT project, you don't have to follow this. You don't have to do this. This is only if you want to use a library in other languages. Visual Studio has built-in support for this. It will automatically be picked up by Visual Studio if you're doing this, and it will apply, it will make you follow these rules. Let's take a look at this. Reusable components. WinRT components, there we go. This one. So, opening up the solution very quickly, and in the Solution Explorer, I'm going to show you in just a second. There we go. That we have two projects. We have a project reusable component, which has a class 1, and then we have a JavaScript WinRT application that has a reference to my reusable component. The first thing, of course, that I have to do to make this possible is set the output type of my library to a WinMD file. If I put this to a regular class library, we can't do this cross-language reusing. Okay, so imagine that I am going to build a JavaScript application that does image manipulation, but I'm not very good at writing JavaScript. I am better at writing C#, so I'm going to write my image manipulation code in C#. but I'm going to use that component from JavaScript. So the things that I have to follow is making this a sealed class, making sure that that my structures that I use only have public types, making sure that I only use system-provided generics. If I don't follow these rules, if you build it now, it's going to work. There we go. If you don't, if you, for example, make this a private in here, I'm going to try building it now, it's going to fail. There we go. It's going to fail. It says here, I hope you can read it, it can only contain public fields. There we go. Now, from our JavaScript application, I'm going to use this particular component, as you can see here. So I say here, reusable component dot class one dot get groups. It gives me a var my groups. I'm going to loop over these groups in my WinRT JavaScript application. There we go. Let's run it. So this is now using my WinMD component, my WinRT metadata WinMD component in my JavaScript application. So there you see it is now doing that, and all the groups in this case are going to be enumerated from my the return in my JavaScript application. Don't think I have any UI for it, but you see that it's actually using the C# library from within JavaScript. Very handy if you're particularly good in one language but have to build your WinRT application in another language. You can move the difficult code to the language you're mostly familiar with. Okay. The last thing that we're going to discuss is background tasks and lock screen applications. Now, many people have asked, what about background execution in WinRT, in Metro? How can we do that in Windows 8? Now, the lifetime of applications, or the lifetime management, is such that only one application can be running in the foreground at any given point in time. Except when you go to snapshot, then it's two. But it basically means that the foreground app receives all the resources from the system. All other apps are suspended. They don't have access to CPU, to network, and to disk. Basically, they are just a memory image that sits there waiting until it may become the foreground application again. The background, however, they don't have access to the background execution whatsoever. However, it is possible to use the background task API where you can write code and only that code is going to be executed in the background. It is not the same code. It is not doing anything with the UI and with your main application. It is a separate DLL that is going to be scheduled to run in the background. Scheduled not in time necessarily, can be in time, but it can be in other, based on other system events happening. Most important point of this slide, it is not the same code. It is other code that you write to be executed at particular points in time to be run in the system in the background. How does this actually work? Well, it is possible to do that using the background task builder. The background task builder allows you to register a class, which is actually which has to be in a separate assembly, and it is going to be implementing something called the iBackground task interface. And that has a method run, and that is going to be the code that is going to execute in the background. Most of the time, it is going to be executed through a separate DLL, separate executable called background task host exe. It can be in process as well. Coming back to that in just a second. So this code can run periodically. Most of the time, it will run in response to system events, and it allows you to do coding, write code that will run when your application is not a foreground application. So in terms of lifetime, the application lifecycle, this is your regular lifecycle. You can be the running app, you can be suspended, and at some point you may get terminated, but your background task will execute in any way in the background. It can run whenever, whatever the state of the application or the main application is. Now, how does the background task actually get executed? The execution is dependent on a trigger, optionally extended with a condition. The trigger is basically what makes your background code execute. The most easy one to understand is a time trigger. A time trigger basically says, well, every, I don't know, this many seconds basically, I want to execute my code. Or a push notification, when a push notification comes in of a particular type, then execute this and this and this code. There are other system triggers, as you can see, for example, the network state change, the session connected, SMS received, internet available, and many others that you can attach to execute code in the background. However, notice that some have a little star attached to them. And that star is very important. The ones with a star can only be done or can only be used if your application is a lock screen application. Coming back to that in just a second. The title of this slide says execution is trigger plus condition. So optionally, you can attach a condition on the trigger before the background code gets executed. That can be internet available, for example, or user present if the user logged on. We've already seen this. Now, this is basically how the entire infrastructure is being set up. You have your Metro style application, and your Metro style application has code that it needs to execute. It can be a background task. And it will say, well, this background task needs to be attached on this and this and this and this trigger. Can be one trigger, can be more than one trigger. Basically, at some point, one of these triggers will get hit, and your code that was registered with the system infrastructure attached to that trigger will then be executed, no matter what the state of your main application is. Notice that at some point, your Metro style application has to register the background task. It is basically required that you do that every time your application runs to keep things fresh. Otherwise, at some point, the background task will get unregistered with the system infrastructure. Now, I said in the condition list that some triggers actually can only be done or be used if your application is a lock screen app. That means that your application is running on the lock screen. I was trying before the webinar started if you could see my lock screen. Apparently it doesn't show the lock screen, so I can't show you that. But the lock screen, no, I was going to check if I have a screenshot in here. No. This is how you change your lock screen. And in the lock screen, so in the settings for the lock screen, you have 7 apps that you as the end user can pin to the lock screen. Those are the apps that you as a user say, well, these apps are important to me. I want to allow them to run on the lock screen. By saying you can run them on the lock screen, or they can run on the lock screen, you give them more permissions on the system. You basically say as user, these are the apps that I'm constantly interested in what they have to say. For example, a mail app. For example, a voice over IP application such as Skype, a calendar application. Those are the apps that get more permissions on the system and can actually attach the execution of background code to a time trigger, or push notification trigger, or a control. I forgot the word. A control channel trigger, which is basically when they listen on a specific channel, a TCP channel, for incoming messages, and then they can also react to that. What they can display is a tile, a toast notification, and a batch. The rest I've already explained here, and I've already said this as well. So as I already mentioned also, the user remains in control. Only if the user places your application there, you have ability to do that. From code, you can request that to be placed on there. You can also check if you are a lock screen application and therefore attach code that only based on that condition will or will not be executed. The resources are metered. That's an important one as well. Here you see that if you are a lock screen app, Windows knows that the user finds you important, and therefore you get more CPU seconds to execute code. This is the amount of CPU seconds you get per period, which is 15 minutes if you're a lock screen app, 2 hours if you are a non-lock screen app, and that is the amount of CPU time you get to execute your background code. This CPU second is quite a lot to do in a CPU second. It's a CPU second completely attached to your background code, so this should be enough for most applications. So let's quickly show them in a sample. Oh, there seems to be something wrong here. My machine is really crashing, it seems. So background tasks. So I'm going to show you the code. I can't really show it running because the code is using the internet available as trigger, and disabling the internet would also disconnect me from the webinar, which is not a good thing, of course. Okay, let's take a look at the code. So let's go to, I already have it open here. Let's take a look at the code. I think it's up there, background task builder. Where are you? Oops, can't find it. Background, oh. Background task builder, where is it then? For some reason I'm looking over it. I'm sorry for this. Okay, that was it. Sorry. So this is the code I wanted to show you. So we have a way of registering a background task with the system. This is basically saying, this is the code that I want to use, and this is when you should be executing it. So everything evolves around the background task builder. What we pass to the background task builder is the name of the class, the entry point basically, that we want to use. In this particular case, that is available in a separate class, in a separate class library, in a class called sample background task, which implements the iBackground task interface and has a method run. We're coming back to that in just a second. So this is the code that we're going to execute. The second parameter is the task entry point and the name of the assembly, if I'm not mistaken. And the third one is the trigger, and that is actually what's going to cause the execution to trigger, optionally passing also in a condition. So that's the name of my trigger. That's what I want to execute. That is, in this case, the name of the namespace dot the name of the entry point class. We set the trigger, which is in this case the internet available trigger, which is available in an enumeration. If there is a condition, we add the condition to the builder. It's possible to add more than one condition on the background task builder. And now we say, builder, register me that task that I've just given you. And it gives me a background task registration. With that background task registration, I can do stuff. For example, I can have communication between my background task and my foreground application. That is possible. Let's take a look at the sample background task to finish this one. So we have a class called sample background task, which implements the iBackground task, and it has a method called run. In that run, this is the code that if I should disable my internet, or enable my internet, this is the code that you would see running. Now, this of course runs and then finishes. If you want to do, for example, a timer, which is basically going on for a prolonged time span, we have to use a deferral, and that's what we get here. So this deferral actually, we actually get hold of the deferral. Then we launch a timer, pass in a callback, and at some point that callback is going to execute. That's what you see here. And that callback is going to finish, and at some point we say deferral complete, basically signaling to Windows, well, the background is finished as well. Now that is a background task. If, however, we want to run for an extended amount of time, we can make sure that the user is going to run my application or going to use my application on the lock screen. He's going to place my application on the lock screen. We can do that from code. We can request the user to do so. If we do that, then only then our application can, for example, use a time trigger or a control channel trigger or a push notification trigger. So I'm going to show you that. In here, I'm going to see if we already have lock screen. As you can see, this application is on the lock screen and has access to real-time connectivity, meaning that it can use a control channel trigger, listen on a TCP channel for incoming messages. We are probably going to cover that in the next webinar on services. So I'm going to remove it. Then I have to restart the application. I think, there we go. Let's restart it. Now we're going to request it again. No, it doesn't seem to be working. Let me do something very dirty and give the application another name. Now it should work. Let's try it one more time. There you go. So now the application requests a permission to run in the background on the lock screen, and then we can use it to, for example, to listen on the TCP channel, or also show batch updates and tile updates in the UI. So I'm going to allow this, and now we could send batch notifications and tile notifications to the UI. The only thing is I can't show it to you. I can try one thing, but I'm not really sure it's going to work. I can try it on a simulator, in fact. Let's try that before we finish. Very quickly, see if it actually works. Oh, I can't show you the lock screen on the... No, I can't do that. I'm sorry. That doesn't work. You will have to run the sample yourself, because as far as I know, I can't show you the lock screen on this one. No. Can't show it. Can't log off here. I don't think I can log off here, and then that is very small for me as well. I'm not going to do it because I'm probably going to mess things up. But now my application is available to or is capable of showing updates, batch updates, tile updates in the UI, and the user remains in charge. In here, in the lock screen, you will have the ability as a user to specify the apps that run on the lock screen. So you can see here, for example, let's put lock screen application CS3 over here. That's the one that you see here now. And these applications can show batch updates. And the one that I select here is the application that can show tile updates as well. And that's the one that appears next to the clock here. All right. So I think we are almost out of time. Quickly, what I'm going to do is I'm going to show you the bag of tricks. That's going to take 1 minute or so before we finish. Instead of showing you the slides, I'm going to show you a couple of cool things that you can do from within your application code. Take a look at the code at your own pace. I'm going to show it to you. We can change the lock screen image. In this case, I'm going to quickly, I can change it. The only thing is, of course, I can't show you the lock screen, so believe me, it has been changed. We can detect the input in the device. In this case, we say we can ask the device, what do you have? Do you have a keyboard? Do you have a mouse? Do you have touch? We can also detect the devices on the machine. In this case, we can, for example, say that we have a receiver, a camera, a flash disk attached, and so on and so forth. This is basically the installed software. And we can also detect the user, as you can see here. In this case, I'm logged in with the Windows Live ID, and it can get access to me as the username. And in this case, it also says it's time to go home. We are already home, but it's time to finish this webinar. So let's quickly go back to the slides. And so I hope I've given you an interesting some interesting points to look at your own pace. Take a look at the demos to get some more insight as well. So I think it's now time to open it up for Q&A.
Yes, Joe. So let's move to our short Q&A session. I've assigned a question to you but
Yes.
don't see more questions. So if some of the attendees have questions, now is the time to send them over.
Yeah. And there's a question from Dale or something. So I think you can see the question. So to put a resource in a separated class type, will it save the load startup time of the application? I imagine that it's not going to do anything different. I'm not really sure. I haven't looked at that, but I assume not. So it's not going to do anything. But it's more or less a management thing. Keep things manageable. Any other questions?
No, Joe. I don't see
it's
any questions. It's
probably too hot for any other question.
Yes, probably. If some of the attendees have questions, they can contact you.
Of course.
After the webinar. So thanks.
My contact information. There we go.
Yes, perfect. Thank you, Jill, for this very informative webinar. And thanks everyone for attending. Now, right after you close the webinar panel, you will see our short survey. If you want, you can fill in your answers, and 3 of you can win an ebook of choice from SilverlightShow ebook market. A recording of this webinar, as well as all demos and slides, will be made available to you and emailed within the next few days. So, thanks again for attending, and have a good day or evening. Bye-bye.